This lesson is proportions and dilations. We're going to start with example 6 from page 145. Just a reminder that a proportion is two ratios that are equivalent to each other. And if we have two ratios that are equivalent to each other, then that means that their cross products will be equal to each other. So if we look at our first proportion, we have x plus 2 over 14 equals x over 10. So we're going to multiply the cross products, which means I'm going to take 10 times the quantity x plus 2. I need to put x plus 2 in parentheses because I'm multiplying 10 by both terms. And that's going to equal 14 times x. Now I need to distribute 10 times x, which is 10x, and 10 times 2, which is 20, and that will equal 14x. Now I'm back to an equation that has variables on both sides. So I need to subtract 10x from both sides. So I have to do the same thing on both sides. The 10x will cancel. I'll be left with 20 equals 4x. My last step would be to divide both sides by 4 if I needed to, but I might already know that x is going to equal 5 because 4 times 5 is 20. You can go back up to the original proportion and put 5 over 10, which is equal to 1/2, and put 5 plus 2, which is 7 over 14, which also equals 1/2. Then you know that x value of 5 is true. Moving on to y minus 15 over 6 equals 35 over 7. I need to multiply the cross products. So 7 times the quantity, y minus 15, equals 6 times 35. Distribute the 7. 7 times y is 7y minus 7 times 15. So 15 times 7 is 105 equals 6 times 35, that's 30, 18, 19, 20, 21, 210. Now, I need to solve for y. This is a basic two-step equation. Do the same thing to both sides. Start by adding 105. 7y equals 315. Divide by 7. 7 will go into 315. Let's do that division. 315 divided by 7 will go 4 times. That's 28. That's 3. Bring down my 5. 7 goes into 35 5 times evenly. So y is going to equal 45. We could go back in and replace 45 minus 15 equals 30. 30 divided by 6 is 5. Is 35 divided by 7 5? It is. Then we know that our equation for y equals 45 is correct. Moving on, we're going to continue to use some proportions and do some dilations with similar figures. We're going to talk about a dilation first. A dilation is a transformation. If you look in your textbook on page 150, it is the yellow term in the middle of the page. The ratio of the dimensions for the new figure, when we do a dilation, a transformation, it's going to change the size of an image. The scale factor is the ratio of change. It's what we're going to multiply or divide the figure by. So if you want to look in your textbook as we do this one, this shape is example 2. Dilating figures on a coordinate plane. Page 150. Let's draw the quadrilateral. Before we can do that, we need to put a coordinate plane on our graph paper. Okay? Now I'm going to graph a quadrilateral. Quadrilateral has 4 sides. I have 1, 2, 3, 4 vertices. Here we go. Point P is at -2, 1, 2, 4. 1, 2, 3, 4. This is P. Okay. Q is at 4, 4. Start at the origin. 1, 2, 3, 4. 1, 2, 3, 4. That's Q. R is at 4, -2, 1, 2. And S is at -4, 1, 2, 3, 4, -4, 1, 2, 3, 4. Too low. 1, 2, 3, 4. This is S. Okay, if we connect those, we see our quadrilateral, similar to what is on page 150. Now, I'm going to dilate this quadrilateral by a scale factor of 1/2. What does that mean? It means I'm going to take each ordered pair, P, was at -2, 4, and I'm going to multiply it by 1/2. So that means I'm going to take 1/2 times -2. That's -1. 1/2 times 4. That is 2. So my new ordered pair for P, or what you might call P prime, is -1, 2. So -1, 1, 2. This is now P prime. I'm going to do the same thing to Q, R, and S. So the ordered pair for Q was 4, 4. Multiply that by 1/2. Q prime, half of 4 is 2, and half of 4 is 2. So Q prime is at 2, 2. 1, 2, 1, 2. Q prime. R. Let's do R first. 4, -2 times 1/2 becomes 2, -1. 1, 2, 1. This is R prime. Lastly, we have S. -4, -4 times 1/2. Half of -4 is -2. Half of -4, -2. So S is -2, 1, 2, 1, 2. S prime. You'll notice that the quadrilateral has dilated to a smaller amount because I multiplied it by -2 or I divided by 2. Let's look at our triangle. Triangle MNP with vertices M at 3, -2, N, 3, 5, and P, -4, 1. Okay, let's create our coordinate plane. And let's graph triangle MNP. So M is at 3, 1, 2, 3, -2, 1, 2. Here is M. N, 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. That is N. P, -4, 1. 1, 2, 3, 4, down 1. That is P. Here is my triangle. Now, I'm doing a dilation with a scale factor of 2. So M is 3, negative 2 times 2. So M prime will become 3 times 2 is 6. Negative 2 times 2 is negative 4. 6. 1, 2, 3, 4, 5, 6. Negative 4. 1, 2, 3, 4. M prime. N prime. So N was at 3, 5. Multiply that by 2. N prime becomes 3 times 2 is 6. 5 times 2 is 10. 6. 1, 2, 3, 4. Whoops. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N prime. You find the result of P prime. Now you can see my green triangle MNP under a dilation of a scale factor of 2. Lastly, we're going to look at indirect measurement. Using proportions are going to be helpful. Okay? Here's the situation. We have a house that is casting a shadow of 56 feet. We have a girl that's standing nearby. She is casting a shadow of 7.2 feet. She is how tall? What is the height of the house? I can set up a proportion. Chloe loves these. Right, Riley? I'm going to take the shadow of the house or the height of the house. Which would you like to start with? Okay, Jack says the height of the house. I don't know the height of the house, so that is going to be a variable. The shadow of the house is 56. Now I'm going to go to the girl. Remember, X is the height of the house, 56 is the shadow. So I need the height of the girl, which is 5.4, compared to the shadow of the girl, which is 7.2. These are similar figures. They are going to be related to each other. So now I'm going to have 7.2 times x equals 5.4 times 56. You find out what is the height of the house. Goodbye, Emily.